Good morning students. I'm back with my new video, and my new video is based on variation of work function with temperature and volume. So as you all know, A is a work function which is equals to U minus Ts. So now what we will do, we will apply a complete differentiation to this equation. And when we apply a complete differentiation, you will get this because it is a general mathematics in which U is the only term, so it is written as du, and here there are two terms. So in complete differentiation, what we do, we first take this term as a constant and take its differentiation, and again when it is kept constant, we take its differentiation. Okay, so we applied the same way and we got dA is equals to du minus TdS minus SdT. So this is your one equation. Now from the definition of entropy, you know that ds is equals to del q reversible by T. So what we will do, we will find out the value of q reversible, and from the thermodynamics, from the first law of thermodynamics, we know that the value of q reversible, del q reversible, is equals to du minus del w. So we will what we will do, if the work is restricted to work of expansion only, so this can be work can be equal to P del V. So this term will be put into this equation, and finally you will get this equation. And now what you have to do, you have to put the value of del q reversible to which equation? To equation 2. So after substitution, you are getting the value of TdS, and TdS is equals to du plus P dV. Now you will put the all values to equation 1. This is your equation 1. So after putting and cancelling it out, because some values are negative and some are positive, so it will be cancelled out. Here du will be cancelled out by minus du, and only these terms are remaining. So this is your final equation. Now in the case of work function, we have two situations. First is when your temperature is constant. So when your temperature is constant, that means dt is equals to 0. So you will apply this condition to equation 5, and on applying this condition, you will get, here this shows that t is constant, and when dt is constant, this whole term will become a 0, and finally after rearrangement you will get this value. Okay, and second equation is when your volume is constant. When your volume is constant, that means dV will be equal to 0. So from this equation, this whole term will become 0, and finally you will get dA where volume is constant, and minus SdT where V again volume is constant. So after rearrangement, you will get this equation. Okay, so this is the relation you can see while relation of work function with temperature and volume.
Start.
Now we will start the second topic, where you will see the variation of Gibbs free energy with temperature and pressure. So this is the very famous reaction, very famous equation, where Gibbs free energy is defined as G is equals to H minus Ts, and you know very well H is equals to U plus P. So on substitution, you will get G is equals to U plus PV minus Ts. Again you have to apply complete differentiation, and on applying the complete differentiation, you will follow this. You will get du plus pdv plus vdp minus tds minus sdt. This is a simple mathematics. Now again from the definition of entropy, you know ds is equals to del q reversible by T. Okay, and again from the first law of thermodynamics, you know the value of del q reversible is equals to du plus pdv. So from here what we are doing, we are finding out the value of TdS. Okay, so the value of TdS is equals to du plus pdv. Now on substituting the above values to equation 3, you will substitute, and some of the common terms will be cancelled out, like du to du, pdv to pdv, and you will get this equation. Okay, so again there are two conditions. The first condition is when your temperature is constant. So when your temperature is constant, dt is equals to 0, and this whole term will become as 0, and you will get this T again shows your temperature is constant, and after rearrangement you get this equation. The second condition arises when your pressure is kept constant. So when your pressure is kept constant, dp is equals to 0. So this whole term will become 0 and you will get this equation. So this was the whole two things which I wanted to tell you about the variation in work function and Gibbs free energy with respective state functions. Okay, thank you.